Hey Algebra 1, Mr. Shachter here to talk about Lesson 9, which is comparing graphs. Let's go ahead and pretend that I'm in the classroom, so please take out your notebook and something to write with, a pen or a pencil. We're going to pretend like we're just doing our normal Desmos routine and working through a new lesson. So the main focal point about Lesson 9 is we're introducing a second graph on the same coordinate plane. And we're trying to pull information about these two simultaneous situations. Let's take a look at an example called population growth. It says, this graph shows the populations of Baltimore and Cleveland in the 20th century. B of t is Baltimore's population in the year t. C of t is Cleveland's population in the year t. So Baltimore's blue, and Cleveland is that dashed red line that you see. Question 1 asks, estimate B of 1930 and explain what it means. So using the graph, looking at B of 1930, now remember that Baltimore is the blue line. 1930B looks to be about right here, in this little red dot that I just drew. So that's approximately 80 or 800,000 people. So B of 1930 is approximately 800,000 people. And what that means, essentially, is that in 1930, the year 1930, the population of Baltimore is approximately 800,000 people. Okay, using that graph, we can pull that information quite easily. Question 2. Here are some pairs of statements about the two populations. In each pair, which statement is true? Be prepared to explain how you know. So the first statement we're going to consider is B of 2000 is greater than C of 2000, or is B of 2000 less than C of 2000? So I'm going to erase my dot here. We're looking now at the year 2000. Here's the year 2000. So the red dot's down here, while the blue dot is up here. So it's clear from the picture, because the blue dot is higher up on the y-axis than the red dot, that Baltimore's population is greater. In the year 2000, Baltimore's population is greater. So we're going to circle this choice right here. The other choice is false. Next one, in the year 1900, is B of 1900 equal to C of 1900? Or is B of 1900 greater than C of 1900? Let's go ahead and look at 1900 now as the year that I'd like to consider. So here's the year 1900. It's the beginning. All right, first year here. The red dot's right here. The blue dot is up above still. Sorry, pen was in the way. Up above still than the red dot. So the population of Baltimore there is still greater than the population of Cleveland. So I'm going to select the second option, that B of 1900 is greater than C of 1900. Last question in this set. Were two cities' populations ever the same? If so, when? Well, for them to be the same, essentially the red line and the blue line have to intersect one another. This happens twice in the graph. Once right here in the year 1910, and a second time right here, approximately, maybe we'll call it 1943. All right, maybe 1942, maybe 1944, something around those 2 years. It's tough to tell exactly. So at two instances, two times, the graphs actually intersect one another. So that happens in the year 1910 and the year of 1943. And again, that's when the graphs intersect one another. Let's go on to a new question. This is wired or wireless. So we're talking about landline phones, if you guys even know what those are. That's a phone actually plugged into the cable in your home, or cell phones. So the graph right here shows H of t, which is the percentage of homes in the United States that have a landline phone in the year t. And C of t is the percentage of homes with only a cell phone. H is landlines, C is cell phones. H is blue, C is red. Let's read the first question. Estimate H of 2006 and C of 2006 and explain what they mean. Let's do H of 2006 first. So H of 2006, we're going to look at the year 2006, which is right here, and we're going to use H, which is going to be that blue line, the landline line. Approximately, I don't know, why don't we call it 82%? 82%. Okay? And then let's do C of 2006. So 2006, the same year, we're looking at C, which seems to be about, we'll call it 18%, just shy of 20%. What each of these percentages mean is that in the year 2006, 82% of people had landline phones in their house, and 18% of people had just a cell phone in their house. Again, this is just data for the United States. Number 2, what is the approximate solution to C of t is equal to 20? Remember, when you see a function notation problem like this, you do not know what the y value, or excuse me, what the x value is, because I gave you the y value. Okay? T is the x value. You don't know what it is. I'm asking you, what is the x value that produces a functional value of 20? Now make sure you look at the correct function, okay? We're looking at C of t, which is the red one. Here's 20. So if we go over and we ask ourselves, where's my function? It's boom, right here. What x value is that? Well, that's 2008. Okay? And what that means is that in the year 2008, approximately 20% of all homes were cell phone only. All right? Let's move on to the next question. And the last one in this set. Determine if each statement is true. Be prepared to explain how you know. Question number 1 in this, C of 2011 is equal to H of 2011. Let's go to 2011. So 2011 takes place just shy after 2010, so it's like right here, 2011. The question is, are these graphs equal at 2011? No way, Jose. The red's down here, the blue's up there. They are not different. This is false. This is false. How about 2015? Okay? 2015 is right here. 2015. They are indeed equal. That's evidenced by them intersecting. The blue and the red line intersect one another at that point. Okay, let's go to the last problem in today's lesson. This one says functions f and g are shown in the picture. F is the little upside down u, and g is the linear blue function. Decide which function is greater for the given input. Be prepared to explain. Okay, step 1, f of 2 versus g of 2. Here's 2. Here's f. Here's g. G is bigger. Simply higher up. All right, functional value is y value. G's got a bigger y value. Let's check 4. Here's 4. Here's f, and right on top of it is g. So in this instance, neither is actually greater. They're exactly equal to one another. So I'll just write that they're equal. Next one, f of 6 versus g of 6. Here's 6, here's g, here's f. This time, f is actually higher, right? The black dot is higher than, well, it's black on my iPad, but it's going to be from the blue function. The f dot is higher than the g dot. Last, 8. In this case, here's 8, here's g, here's f. F is still just a tiny bit higher than the g function. So f of 8 is greater than g of 8. Is there a value of x for which the function f of x equals g of x is true? Well, there's actually 2. If I'm going to zoom in on this graph for just a quick second here, there are 2 points in which the functions are actually equal to one another. They occur at 4 and at 9. Okay? So at x equals 4 and x equals 9, the functions are actually equal to one another. Identify at least 2 values of x for which the inequality f of x is less than g of x is true. Okay, so I need to pick values of x for which f of x is smaller than g of x. All right, here's a bunch of them. 1, 2, 3. Let's skip over to the end. How about 10, 11, and 12? Or 11 and a half, I suppose. All these values, those black dots, are smaller than the blue linear function. So I'll just pick 2. I'll pick x equals 1 and x equals 2. Here's a quick summary of everything that we saw in today's lesson. Feel free to pause and read it over if I can fit it on my screen. There it is. Take a peek. Okay, it is now time to go to Canvas and take a look at the Lesson 9 practice problems. Your task right now is to work on them and hopefully complete them before tomorrow. Have a good day.